So, here we are. We're going to be starting chapter 7, and it's actually chapter 7.1. So this is 7.1. You should have the 7.1 notes. So let's have a look at what we've got here. So this chapter is about multiplying and dividing polynomials. Now, in chapter 5, we spent a lot of time understanding things about terms and coefficients and variables and like terms, and we did adding and subtracting, didn't we? So here we're going to begin. Our first example here has to do with multiplying monomials. So let's have a look at what we've got. We've got a monomial 5x times 2x. Now we're going to look at this in two different ways. We're going to begin by looking at method 1. We're going to use a model. Now, if you remember back from chapter 5, of course, each of these little rectangular squares, of course, represent just a single x, don't they? And we can think of it here, we can set up our multiplication a little bit like this. And we've got a times there like that. So if we go through our first one here, we've got, well, look at what we've got. We've got 2x's arranged vertically, and we've got 5x's arranged across the top there like that. So what does an x times an x give us? That gives us an x squared tile. So what we need to do here is we need to keep on filling things in here with x squared tiles, and it's like an area model, isn't it? And we go there, and coming over here, and it's going to take a moment to fill them in. So while you're looking at this, you can fill in your page with the same thing here. So of course, each of these represents an x squared. Now, how many of them have we got here? Well, pretty obviously, we've got a total of 10x squared. Now, method number 2, how would we think about this algebraically? Well, we've got our 5x times our 2x. Now, I'm simply going to jumble the factors around a little bit. We've got 5 times 2, don't we? And then we've got x times x. So, 5 times 2, clearly, we've got two coefficients there. That gives us a total of 10. X times x, well, isn't that just x to the power of 2? Now, that was pretty easy, wasn't it? And, of course, algebraically, it's certainly a nice, quick way to do it rather than thinking about it with tiles. But the tiles provides us with an alternative. Now, let's go on and have a look at b over here, looking at this. Now, we've got two coefficients. Well, we've got two monomials to start with. We've got the 3x and we've got the 2y, don't we? Now, this time, of course, we've got two different variables, so it's a little bit more awkward doing the area model. So I'm simply going to look at this one algebraically. So we could think of this, well, we've got, taking our two coefficients, we've got 3 times 2, and then we've got x times y. 3 times 2, of course, is going to give us 6. Now, x times y, well, two different variables is simply still going to leave us with an x times y. All right, so 3x times 2y simplifies to simply give us 6xy. Okay, so why don't you pause the tape here at this particular point, and you can go through and show and determine these two products here. So we're going to pause the tape here and come back in a moment. So is this what you got? So for the first one here, I did, well, joining my two coefficients together, 4 times 2 is 8, xy. And then this one here, now we've got a negative sign here, don't we? That's like a coefficient of -1. So we could think of this as being like -1 times 7 times x times x. So -1 times 7 is the -7 there, and x times x can be simplified to x squared. Right, let's pop over to the next page here. Now, this one here, example number 2, applying monomial multiplication. What is an expression for the area of the rectangle? Now, Rectangles are really easy to work out with area, aren't they? What is it? It's simply going to be the product of length times width. So, what have we got? We've got our length is actually a monomial, 4.3x. Coefficient is 4.3, isn't it? And then our width, or maybe our height, we could think of it as, is 2 times x. Now, putting down 4.2 times 2, and then we've got x times x. So, working out, can we use mental math to go through and work out 2 times 4.2? Well, 2 times 4 is 8. 2 times 0.2, 8.4. And that gives us 8.4x squared. So, an expression for the area here is just the single term 8.4x squared. All right, why don't you go through now, and you can pause the tape and have a go at these two here for under the show you know. So do this one and this one here. Pause the tape and then start it up again in a moment. So is this what you got? 11 times 2, multiplying our two coefficients, and then the variables a and b, 22ab. B, all right, we've got minus 5 times 3.2, which is 1 negative, 1 positive, gives us negative 16, and then simply the single variable x. Okay, let's have a look at this here now. We're going to go through and we're going to look at dividing monomials. So looking at what we've got first here, we've got a monomial on we've got a thing called a quotient, don't we? All right, it's a division. Looks like a fraction, but it's made up of little algebraic terms. So we've got a monomial on top, and we've got a monomial on the bottom. 10x squared divided by 2x. We're going to begin looking at this using our algebraic tiles. Now, before we do that, let's think about how things work in multiplication tables. So I've got this little table here, and you can see here I've got 3, there's my 3, times the 4 is equal to 12. Now there's other ways that we can think about this as well, isn't there? So we can think of, if we thought of 12, and if it was 12, if we read it backwards, 12 divided by 3 is equal to 4, isn't it? Or we could think of it as if we took 12 and we divided it by 4, so 12 divided by 4 gives us the 3 there like that. Now, what we've got here is, we've got our top shelf, our numerator is the 10x squared. And we can imagine here, we're dividing it by 2 x's. So x, we've got an x there and an x there. So 10x squared divided by the 2x, which is a little bit tight there on the corner, isn't it? Now, what's that going to look like? Well, if we complete the model here, we would be taking little x's and putting them up here, wouldn't we? So if we imagine doing the multiplication but doing it kind of in reverse, doing it backwards, which is really what division is anyway, isn't it? So this is what we end up with here. So checking this out, along the top here we've got, of course, these are all x's, and so we end up with a 5x like that. Now think about it here. On the vertical here we've got 2 x's, along the top there we've got 5 x's, and we know 2 times 5 is 10, x is 10x squared. So that's the right result here, isn't it? Okay, when we think of it as an equivalent multiplication. So it would seem that 10x squared divided by the 2x is equal to the 5x's along the top there like that. Now, I'm not sure that a model is sometimes terribly helpful like that. It's certainly a little bit more straightforward, I think, to think about it algebraically. So method number 2 is algebraic. Now, if I take the top line and I write it as 10, x squared can be thought of as just x times x. So I'm expanding it out. On the bottom shelf, we've got 2x, don't we? Now, let's look at our coefficients first of all. This part here, 10 divided by 2. Well, that's easy mental math, isn't it? That simply leaves us with x. Now, let's look at our variables now. First of all, we've got x divided by x. Now, x divided by x, or simply x over x, that must be the same thing as 1. So it's as though the x's, we sometimes use the word cancel out and give us 1. And we're left with a single x by itself there, so the answer there is 5x. Okay, let's do the one next door there. Look at what we've got. Now, I'm not going to use a model for this one. I'm simply going to use an algebraic method. So we've got 8xy, and on the bottom we've got 4x. Now, what do we do to start with? We deal with our coefficients first of all. 8 divided by 4. Well, that's a nice easy one, isn't it? That leaves us with 2. Now, the next thing, let's have a look at our x variables there. We've got x, 1x on top, 1x on the bottom. X divided by x leaves us with simply 1. Multiplying by 1, we don't worry about putting that in. And then we've got a single y by itself, and it's on the top there like that. So that's what we end up with. We end up with simply 2y. Okay, now remember, it's as though it were 2y over 1, because effectively we've got a 1 over 1 there for the x over x, but when it's a denominator of 1, we usually don't worry about putting it in. So let's pop over to the last question here. I'd like you to go through and take a moment to go through and simplify each of these quotients here. And you can do these ones algebraically. Now, did you get what I got? 12xy divided by 3y. Well, first of all, the 12 divided by 3 is 4. xy over y simply leaves us with 1. They cancel, and we're left with 4x, aren't we? And then the next one here, looking at the coefficients of our monomials, negative 14 divided by 2 gives us negative 7. I expanded out the x squared. When I say expand, I wrote it out as, instead of x squared, I wrote it as x times x. X over x leaves us with 1, and we're left with just a single x, negative 7x. Okay, so our last example is this one here, isn't it? So let's have a look at this. Applying monomial division. The area of a rectangle, or triangle rather, is given by the expression 18x squared. So that's a little odd, isn't it? The area is not actually a number that we know. It's given to us as an expression. Now, we know that x is a variable. X could represent any number. So the area is just simply 18 times whatever this number is, x is, and it's squared. Now, it says there we've got the base of the rectangle along there like that is 4x. And that's the height of the rectangle there, putting that in. Now, it says there, this is the question that we have. What is the height of the rectangle in terms of x? Now, we have to remember back to a formula that we did in grade 8. Area of a triangle is the base times the height divided by 2. Now we need to adjust this. We need to change this formula around a little bit because we want to express it in terms of h. So if we do a little bit of algebraic manipulation here, if we multiply the area by 2 and we divide by the base, changing the formula, we can write height is 2 times the area divided by the base. Now what we're going to do here is we're going to substitute or replace the area with the expression for the area, which is 18x squared, and we're going to substitute or replace the word base with the term for the base, which is 4x. And of course it's all multiplied by 2. So let's write that out, shall we? So I'm going to use h for height instead of writing it out. I've got 2 times the area, which is 18x squared, all divided by my base, which is 4x. Now, let's look at what we've got. Now that 2, we can join like this. 2 is like having 2 over 1, isn't it? So we can go through and we can multiply out our top line there. We've got 2 times 18, which is 36, x squared. I'm going to write it as xx. On the bottom, we've got 1 times 4, or simply 4x. Now, we've got 2 monomials. We can go through and simplify them. So first up, let's look at this here. We've got 36 divided by 4. 36 divided by 4, oh, mental math here, that's equal to 9. X over x makes x divided by x is 1. It cancels out, and we're left with a single x there like that. So there we have it. So the height, when we express the height in terms of the area and the base, we get another algebraic expression. The height is just equal to 9x. So we could come up here and we could say, there's the height is equal to 9x. Now we could go through and check it out by using the formula for area. Area is equal to 1/2 times the base, which is 4x, times the height, which is 9x, and you can do that multiplication. 4 times 9 is 36, so you get a 36x squared there, times 1 over 2. 1/2 times 36 is the 18x squared, which is what the area was to start with. So that's sort of double checking that we actually did the right thing there. Okay, so your task when you next come along to class is to work from, this is exercise 7.1, and it begins on these pages here, and you want to work through these numbers here. Good luck with that.